This is Mr. Anderson for Kellogg Community College. We are looking at Chapter 5, Section 4, Factoring Trinomials, the easy and difficult types of factoring. We're going to start off with this two-part video, and the video will be broken into two spots, one for the easy ones, where the first term is the x squared only has a 1 in front of it. And then we'll have a second video to follow, which I will be showing you my techniques for solving where the x squared has a non-1 number in front of that, and how we will deal with that. So these are relatively easy because what you'll have to do is think of all the ways that you could factor the third term to make the middle term. Because in the FOIL of first, outside, inside, last, because all of our answers are going to look like two sets of parentheses here with an x inside the first parts of those parentheses. What we're really trying to do is we're trying to look at how we can get the middle term to be made by the end terms, or how does the O and the I cable get made from the last factors of this number. Since the f or first term has an x squared in it, we're always going to have 1x and 1x, so we don't have to worry about it. But now we just got to think of the correct combination. So the first case is really to ask what two numbers multiply to make the third term and at the same time add to make the second term. So that's the question that you'll have to ask yourself when taking a look at this case. So what two numbers multiply to make the third term and add to make the second term? Well, we'll just factor the third term and see what its factors are, 1 and 8 and 2 and 4. Now, what two numbers here multiply to make 8 and add multiply to make 8 with these two combinations and add to make 9, and this is the winning combination. So my answer is x plus 1 and x plus 8. You can go to FOIL and see that this would work, and this always kind of brings up the question, well, what if I put x plus 1 and x plus 8? Because multiplication is commutative, you can move them, or you can have the parentheses in either order. Okay, so how about 14? If you look at all the factors of 14, I got 1 and 14, 2 and 7, and the ones that make 9 are the last two, so this becomes my x plus 2, x plus 7. And this is why it's called the easy factoring of trinomials. It is very common, and it should go pretty quickly, even when you have a number like 12 that has a lot of different ways you can factor. You can divide 12. You've got 3 different combinations, and since 12 is positive, we only have to think about the positive ones. So here I have x plus 12 and then x plus 1, because that's the combination that makes 13. Now, with a negative in the middle term, things get a little bit trickier, but let's first of all list all the factors of 40. 1 and 40, 2 and 20, 3 doesn't work, 4 and 10, and then 5 and 8, and then 6 doesn't work, 7 doesn't work, and as soon as you go to 8 and 5, you'll notice we'll be backing up the chart again, so we're done listing all the factors. So you'll notice that this is a minus. So you have to consider both of these being minus because, or a negative number, because negative times negative is positive. So when the middle number is negative and the last number is positive, you have to think of a double negative to make a positive, and then one of these pairs makes negative 13, and that would be the last one. So this is going to be x minus 5, x minus 8. So when you, again in review, if you have a second term that's negative and a third term that's positive, you need two negatives to make a negative in the middle and to make a positive for the third term. So we're moving on to next couple problems here, and 4 more, and then we'll be done, and we'll move on to the next video. So in this case, I have another problem that has a negative middle term and a positive third term. So let's list all of these with negatives in front of both of them. And you'll notice that this is the combination that works here. So I'm going to have x minus 4 parenthesis x minus 4 because that makes a positive 16 and negative 8. I could FOIL to check my answer, but you'll maybe see in the back of the book that this will be written like this, which is the way that some of your problems in section 5 or chapter 5 section 2 are written. So yes, you can leave it in either form. This is the more simplified form. Now the last couple problems here, you'll notice that there are looking at this one here, you'll notice that the third term is negative and the second term is positive. If the third term is negative, you not only have to look at a combination that would make a negative 28 in this way, but you also have to look at it in this way with a positive 1 and negative 28, because that will give you a different middle term based on what you see. So this is negative 2 and 14, and this is 2 and negative 14. Now, at this stage of the game, when I'm listing so many different ways to factor a problem, I'm checking each one as I write them. So these didn't make a 3, and these didn't make a 3. So we're going to move on to the next one. 3 doesn't work, but 4 does. So negative 4 and positive 7, that makes a 3. I'm not even going to write down the other option, which is 4 and negative 7, because that would make a negative 3. Conversely, if you find that there's one option that makes an opposite middle term, it's probably you're really close and you just have to choose the other way to do it. So in this case, I landed right on the spot, x minus 4, x plus 7, and if I do my FOIL, that will work to make a positive 3x in the middle. Now, these two problems here, this one, I wanted to point out that sometimes when you list the factors of a problem like 1 and 5 and 1, you might think to yourself, oh wow, 5 and 1 subtracts to make 4. But unfortunately, since we're only using whole number answers here and we're not using the quadratic formula, this is prime based on the technique that we're using. So it's prime because 1 and 5 make 6, and there's no other way to make a 5, so this is a prime answer. So there's nothing left to do in this problem. So be aware that there are some prime answers in this one. You might say to yourself, well, wait a second, what about, just subtracting the 1 and adding the 5? Well, there's a problem with that because a negative 1 and a positive 5 don't make a positive 5. So that is not the right factoring answer. And especially I want to point out that on the worksheets and tests and quizzes that I'll be doing, it might seem like, oh, Mr. Anderson, it looks like you made a typo here. That should be a minus. And I'll be like, no, I didn't make a typo. You should know what to do in this situation, and that is prime. Last problem here, you'll notice that we'll again list negative factors here because we are trying to get two negative numbers to make 21 and then the two numbers to make the middle here. And I think some of you were probably thinking a little bit in the future and saw that happen right there. So there's my answer to that problem. Please stay tuned to the next video. Watch that if you have, because these difficult problems are a little tricky, and I do have some pretty good tech to make them as fast and as efficient as possible.